Alright, questions that we had that we weren't able to go over today in class that people had asked about. We had 3 through 8, so I'm just going to start working my way, starting with number 3 and working through number 8, and then we'll skip around a little bit after that. But let's look at number 3. This one's actually pretty straightforward because it asks which ordered pair is a solution to the following system of equations. Our first equation is x equals 5. Well, think about this. If x equals 5, then it's a pretty safe bet that your x-coordinate has to be 5. And then our second thing is y equals 0, which means our y-coordinate would have to be 0. So this one's pretty straightforward because, or if you thought about it graphically, the line x equals 5 is 5 units to the right of the y-axis, and the line y equals 0 is the x-axis, so the point where the two meet is where your x value is 5 and your y value is 0, thus 5, 0. Now, the next one's a little bit more challenging. This one is a problem where we are looking at a system that actually has some more work to it. You can use any method that you would like. Since they're already both solved for y, I think substitution is a good method to use here. So here, if y equals 2x plus 3 in the first equation, then I can replace y with 2x plus 3 in the second equation. Then I can go to solve. Now this time I have variables on both sides. So the first thing I need to do is move them to one side. So I'm going to subtract 2x from this side, which means I also subtract 2x from that side. But here we have the unusual thing happen, which is 2x minus 2x, that's eliminated, but 2x minus 2x there also cancels out, which leaves me with positive 3 on the right-hand side and positive 7 on the left-hand side. So we have the statement 3 equals 7. No variables, both variables canceled out. And 3 never, ever equals 7. No matter what you let x or y be, 3 will not equal 7, so 2x plus 3 will never equal 2x plus 7, which means there's not going to be a number or a coordinate that solves both equations. So this tells us that there is no solution because this is never true. Alright, so let's look at number 5. 5 is kind of the opposite of this problem. This one, again, we can solve using any method. Again, I already have a y equals, so substitution seems like a good choice. So I'm going to replace y here with 5x plus 1, so I get, so that goes in there. So my new equation is negative 5x plus 5x plus 1 equals 1. Now, when I still wrote those parentheses because we're adding all of it, but since addition doesn't change the sign or anything, really, we can drop those parentheses off. So really we get this. And now we can combine like terms. So negative 5x and positive 5x is 0. Plus 1 is 1. And so I get 1 equals 1. Well, if you look at that, when does 1 equal 1? Always. Once again, my variable terms all canceled out here, so I'm left with just a number equal to number. But the difference between this one and the previous we had 3 equals 7, which is never true. Here we have 1 equals 1, which is always true. So our solution is D. There are an infinite number of solutions. Now, simple reason why that holds true. If we had actually solved this second equation and put it in slope-intercept form, I'd need to add 5x to both sides and I get y equals 5x plus 1. And you might notice y equals 5x plus 1 looks a little bit familiar. It kind of looks exactly like the first equation. The reason that this system has an infinite number of solutions is because that system of two equations is really the same equation twice. So obviously anything that solves the first equation will solve the second one because they're the same thing. Alright, so let's look at now at 6 through 6 through 8 are all talking about the best way to graph these equations. Now, we've talked about this a little bit in class, and you may have a preferred way, but there's a best way, a way that's easiest for each one. If you look at the first one, x equals 6, we've talked about before the fact that x equals is a line that is parallel to the y-axis, meaning a vertical line, and it crosses through, obviously, where x is 6 and y is 0. So you should have memorized that it's a vertical line through the point 6, 0. Could you make a t-table for it? Sure you could. You could plug in and say, okay, x is 6, y is 0, x is 6, y is 2, because no matter what you put in for y, x is going to be 6. But that's not very efficient. Really, the most efficient thing is to realize that, hey, I should just have memorized x equals 6 is a vertical line through 6, 0, and be done. Same thing with y equals line. That should simply be memorized, that it's a horizontal line going through the point 0 and then whatever your y-intercept is. Alright, so the next one, we have x plus y equals 7. Now, obviously, this is not a horizontal line, and it is not a vertical line, which means the only options you have left are making a t-chart or plotting the y-intercept and using the slope. Now, to plot the y-intercept and use the slope, that means you need to have it in slope-intercept form. So look at this equation. Is that in slope-intercept form? No. So the best method to use here is going to be making a t-chart, because the equation doesn't start out in slope-intercept form. Now again, this is a matter of opinion. As far as I prefer slope-intercept form, so I usually do most of them. I'll rewrite it. But as far as the most simple way, because I mean, look at this, x plus y equals 7. Well, if x is 3, then y would be 4, because 3 plus 4 is 7. If x is 2, then y would be 5, because 2 plus 5 is 7. So it's pretty easy to plot an x and y on a t-table and to be able to solve this one. Which gets us down to number 8. Once again, not a horizontal line, not a vertical line, because it's not x equals something, it's not y equals something. So we have t-chart or the y-intercept and slope, and if you look at this equation, it is in slope-intercept form, which is why we know that B, using the y-intercept and then the slope, is going to be the most efficient way to graph that equation. So, if it's an x equals line or a y equals line, you should simply have it memorized. If it's not in slope-intercept form, if it's just a standard equation, then you should make a t-chart. And if it is in slope-intercept form, then your slope and y-intercept are going to be the best way to graph. Now number 13 is the next one people had questions on, and this one is solving the system by elimination. So remember, a lot of people get hung up on, oh, well, my x's aren't the same. Remember, it doesn't have to be your x's that are the same, it can also be your y's. So here I have 1x and 6x. Well, those won't eliminate. But I have 1y and negative 1y. Well, those will eliminate because they're the same coefficient, but one's positive and one's negative. So I can simply add the two up. So I get 1x plus 6x, which gives me 7x. 1y and negative 1y cancel out. Negative 4 and positive 4 cancel out. But that doesn't mean there's nothing there. It means there is 0 there. Remember, 0 is a number. Don't let it freak you out. From here, I divide by 7. Once again, you can divide 0 by 7. If you have 0 people, how many groups of size 7 can you make? Well, 0 of them. So 0 divided by 7 is 0. That's our x value. Then we can plug that into either equation. Personally, I like the first one. So I'm going to do x plus y equals -4 and replace x with 0. So 0 plus y equals -4. And of course 0 plus y is y, so I get y equals -4. And that is my solution for number 13. So the next one that we have is question number 15. Now for number 15, we're given our choice. We can use any method that we would like, from substitution, elimination, or graphing, to solve this one. So it's completely up to you which one you would like to use. Personally, since I already have a y equals here, I would want to go with substitution. If you're going to do elimination, you need to understand that for elimination, your x and y have to be on the same side of the equation, and your constant needs to be on the other. So let's say I was going to solve this one using elimination. Then the first thing I would have to do is add 2x to both sides of the equation on the second equation. So that way I would have 2x plus y equals 0. So that way I could line these up, and then I would still have to multiply through by something, because 2x and 3x don't cancel out, and 1y and 2y don't cancel out. So I'd have to multiply the first equation through by like -2, so that way I'd have -2y to cancel out. So you can use that method, but once again, just like with the questions 6 through 8 that we just looked at, you can use any method, but that doesn't mean there's not a best one. Here, since I already have something in y equals form, a good choice is substitution. So I get 3 times x plus 2 times y, but from the second equation I know y equals -2x, so instead of 2 times y, I'm going to put 2 times -2x. So that equals 2. So that's just this equation here, but replacing y with -2x. So then I do order of operations. 3x minus 4x equals 2. 3 minus 4 gives me -1x equals 2. And dividing through by -1, I get x equals -2. Then to find my other value, I'm just going to plug in. So y equals -2x becomes y equals -2 times -2, which means y is going to equal +4. So that's how we do number 15 using substitution. Now, let's look at it doing graphing as well, just so you can see the difference. So before I graph it, the first thing I'm going to need is I'm going to need to rewrite the first equation in slope-intercept form. So if I take 3x plus 2y equals 2, I need to get y by itself, which means I need to get rid of 3x, so I'm going to subtract it. And then I get 2y equals -3x plus 2. And then to get y by itself, I have to divide through by 2. So I get y equals, and remember you have to divide every term by 2, so -3 divided by 2 is -3/2 x. And 2 divided by 2 is 1, so I get y equals -3/2 x plus 1. And then I also have the equation y equals -2x. So let's look over at the graph. So for the graph, we had our two lines, which were y equals -3/2 x plus 1, and y equals negative 2x plus 0, because if you don't see the y-intercept, that means you're adding 0. So graphing the first of these two equations that I've written down, I've got a y-intercept of 1 and a slope of negative 3/2. So I'm going to go down 1, 2, 3 and run 1, 2, and that puts that point on my line. And if I do it again, down 1, 2, 3 and to the right 1, 2, then this point's also on my line, and then I can connect them. Again, making sure that they're nice and neat. And then my other graph is going to have a y-intercept of 0, but a slope of negative 2, so I'm going to go down 2 and to the right 1, down 2 and to the right 1, or up 2 and to the left 1. And here's a place where my line didn't come out quite straight, which is going to mess me up a little bit here. So, because this should actually be where they meet, but my line ends up a little bit off. So again, being able to draw a nice straight line is a good idea. So from here, I can connect my points. Oops. So I get my line doesn't want to cooperate. Alright, so a little bit hard to see, unfortunately, but if we look, we can find our solution to both. So our solution is this, which is negative 2, 4, which is the same thing as we got by substitution or elimination, but again, a little harder to see on the graph just because my lines didn't come out quite straight, which is why it's a good idea to do your slopes instead, and do rise of 2, run of 1, or rise of negative 2, run of negative 1, however you need to do it, and then find your point that way. Alright, so that is that one. So let's go ahead and look at the next. Alright, so this is number 18. For 18, once again, you get to choose whichever method you would like. Looking at these, again, that's not already in standard form, so it's not x, y equals constant, it's, a y equals. So since it's already got a y equals, I would lean towards substitution here. So I would take what y equals, which is 2x plus 1, and replace y in the other equation with that. So that gives me x plus 2x plus 1 equals 7. Again, I could put parentheses around that 2x plus 1, but since I'm not multiplying by, I'm adding it. Again, and because it's adding, not subtracting, I can go ahead and leave them off. So I get 1x plus 2x, which gives me 3x plus 1 equals 7. If I subtract 1 on each side, I get 3x equals 6. And then divide by 3 on each side, and I get x equals 2. So that's the first part. Then plugging into an equation, say the one I've circled earlier, y equals 2 times x, which is 2 now, plus 1. 2 times 2 is 4, and 4 plus 1 is 5. So my y value would equal 5. So our solution is 2, 5. I'm not going to show this one graphically for the sake of time, but if you graph it, you will get the exact same solution. Or if you rewrite it and put your x and y on the same side and then solve by elimination, you'll also get the same thing. Alright, so let's look at number 19 next. So 19 is a word problem. Now, again, they kind of help you out in the fact that they tell you that X is going to represent the number of nights that you're staying in the hotel, and Y is going to equal the number of points. Now, obviously, Y is going to be something related to the number of nights you spend. You're going to earn more points based on more nights. So it says Marvin is considering signing up for a hotel rewards program. Hotel Elegance is offering 60 points for signing up. Now those are one-time points. He doesn't get them for every night he stays, he only gets them one time. Plus, there's a math word for you, plus 85 points for every night. So 85 points, but not just once, 85 points per night. Which means if he spends one night, it's 85 times 1. If he spends 3 nights, it's 85 times 3. If he spends X, because X is the number of nights, then that would be 85X. So 85 times the number of nights he stays plus the 60 sign-up points would equal the total number of points he earns. Now, the other hotel is offering a sign-up bonus of 62 points. Once again, that's a one-time bonus. Doesn't matter how many times he stays after that, he just earns that for signing up. And then he also earns 83 per night. Again, plus, so we know we're adding. And he's earning 83 per night. Again, multiplied by X number of nights. And that should equal the total number of points. So now we have two equations, y equals 60 plus 85x, and y equals 62 plus 83x. Now if you'll look at our options up here, they can be in reverse order. The important thing though, I know it's not A because it says y equals 60x plus 85, when really 60 is by itself and 85 has the x. So because 60 is the one-time term, we're not multiplying it by anything. So we know it's not A. If we look at B, we've got y equals 85x plus 60. Well, that's that equation, just rearranged. First the y, then the 85x, then the 60. But everything has the correct signs. And the other one is y equals 83x plus 62. Once again, that's just y equals 83x plus 62. So same equations, just reverse order. So that means that B is the solution for number 19. Alright, so only one question left. This one's also a word problem, number 20. Only difference is this time instead of talking about a number of nights staying and a nightly cost, this is talking about the number of cookies on a tray and the different size trays. So we have the caterer who's making the trays for the holiday party. It says she made one large tray and 3 small, which contained a total of 109 cookies. Well, total always tells me that we are adding. So the number of cookies on the one large tray plus the number on the 3 small trays should equal 109. Then it says in the afternoon she's going to make one small and 2 large. And the total, so once again, total tells me that we are adding. The total of those trays is 128 cookies. So now we need to write an equation. Well, here the number of cookies on the large tray is y. They told you to use y. So I can replace large with y. So I have 1y and 2y. And x is the number of cookies on a small tray, so I can replace the small with x and x. So my first equation is y plus 3x equals 109. And the second one is 2y plus 1x equals 128. Now that's the first part because we still have to solve the equation. But once we've written the equations, now we can choose what method we want to use to solve them. So, again, substitution seems like a good choice, but you could also do elimination. Now, one thing about elimination is if you match them up, here I have 1y and here I have 2y. Different coefficients, so I can't just add or subtract. Here I have 3x and here I have 1x. Once again, different coefficients. So I need to multiply by something to make their coefficients the same. So since this is 1y and this is 2y, I can multiply this whole equation by -2, and that would give me -2y. I know I can do that because as long as I do the same thing to both sides, the equation is still true. So I get -2y minus 6x equals -218. And now I can line them up and add them to eliminate. So 2y plus 1x equals 128. The y's eliminate. -6 plus 1 is -5x. -218 plus 128 is -90. And if I divide through by -5, I get x equals +18. And then plugging into either equation, I get y plus 3 times 18 should equal 109. 3 times 18 gives me 54. So I get y equals y plus 54 equals 109. And then subtract 54 on both sides, and I get y equals 55. So my solution is 1855. In other words, 18 cookies on X, the small tray, and 55 on Y, the large trays. So that's all the ones that you guys had questions on that we didn't get to in class. So hopefully that answers any questions you have. Make sure you study, review everything. Remember, you can always check your solutions by plugging them into your calculator. And make sure you come ready to work because there will be no extra time on the quiz, on the test tomorrow. So you've got to get it done during the 49 minutes of class. All right, I hope you guys are get some good rest tonight and come in ready to do well tomorrow.